Wave-particle duality of light is extremely intriguing. People tell you sometimes light behaves like a particle and sometimes it behaves like a wave, but waves and particles seem to be two awfully different things. So that comes across as something really uncomfortable at first glance. I mean, why does light change its behavior like that? So let me try to explain what this means. But before that, let us take a look at a brief history of this whole debate and how this confusion came about. So the idea of duality came about in a debate over the nature of light and matter that dates back to the 17th century, when two brilliant scientists couldn't exactly agree with one another. So there was Christian Huygens, who thought that light was a wave, but Isaac Newton came along and he begged to differ. He thought that light was made up of a bunch of particles called corpuscles. So if you come across something you're unfamiliar with, what you do is that you do a series of tests on it to find out what it is, right? So that's exactly what scientists did. Scientists, over a couple of 100 years, did various experiments in order to study the properties of light and determine whether light was a wave or a particle. I won't go into the details of every experiment because each one needs an entire video to explain it well, and that's not the focus of this video either. But let me highlight two of them in this video. So the first one I'd like to highlight is the double-slit interference experiment. Scientists, through the double-slit interference experiment, found out that light rays can interfere with one another. And since only waves can interfere with one another, light has to be a wave. So in order to understand this better, we need to know what is interference. So if you look at this diagram, well, these two waves have equal amplitudes. And you see that the troughs and crests of the two waves are completely aligned when they meet. So when this happens, the waves add up, and you get a wave with an amplitude twice of that as the previous two waves. This is called constructive interference. If you look at this one, well, again, the two waves have equal amplitudes, but now you see that the trough of one wave aligns with the crest of another and vice versa. And when this happens, the waves cancel each other. And so you get a wave with an amplitude of 0. This is called destructive interference. And in fact, it's interference that causes light to display this pattern on the screen when it is shined through two small slits, giving rise to the famous double-slit interference experiment. I won't be explaining how this whole thing happens in this video because that could take up an entire video on its own. So I'll leave you to think about this in your free time. But the point is, scientists thought the double-slit interference test proved, without a doubt, that light is a wave, because only waves can interfere. So in a similar way, the results of another critical experiment, called the photoelectric effect, can only be explained if light was made up of particles. What is the photoelectric effect? Okay, well, let's say you have a piece of metal. That's my metal over there. And we know the metal has electrons. And these electrons are bound to the metal because they are attracted to the positive charges in the nuclei of metal atoms. And of course, there are plenty of electrons in the metal, but I've just drawn one of them here for simplicity purposes. So if you shine light on the metal with the correct kind of frequency, you can actually knock this electron out of the metal. And not just one electron. You can actually knock a bunch of electrons out of the metal, which causes a current of electrons to flow. And this is called the photoelectric effect. Now, before 1905, there was a bunch of different things about the photoelectric effect, which scientists had a lot of trouble explaining. And one of them was that red light does not cause electrons to be kicked out, no matter how brightly you shine it. So Einstein came along, and he took a look at this problem, and he said, well, wait a minute. What this tells us is that light has to be made up of a bunch of particles called photons. Each photon is a little packet containing a certain amount of energy. In the photoelectric effect, each photon collides with a single electron to kick it out. And so as long as the colliding photon contains enough energy to kick out the electron, then, well, you see the electron kicked out. The amount of energy that each photon contains depends on the frequency of the light, not how bright the light is. So what does the brightness of the light determine then? Well, The brightness of the light determines the number of photons you have in the red light. The brighter the light, the more photons emitted. So for the photoelectric effect, the brighter the light, the more photons emitted, and the more electrons you see kicked out, provided individual photons each have sufficient energy to kick electrons out. Red light is a low-frequency light, so each of the red photons had too little energy to kick an electron out, no matter how brightly you shine the light and how many photons were emitted. So in brief, Einstein's explanations of the photoelectric effect on the basis that light was made of particles was a perfect match with experimental observations. The photoelectric effect experiment showed us that light can exhibit particle-like characteristics too. So now that we understand how light behaves when we do different tests and all, let's get back to the original question, and let me put it in super big font. What is light? Okay, so think about it this way. We're all really familiar with three items in our pencil case, right? The pencil, the clicking pen, and this guy in between, the mechanical pencil. Suppose one day an alien visits your house, and for some reason he wants to study the stationery that humans use on planet Earth. So he looks into your pencil case, sees the pen and pencil, and gets really excited, because apparently they use pens and pencils in his planet too. So he goes like, hey, that's cool, you guys use the same stationery, pens and pencils as us. But then he looks deeper into your pencil case and sees something else he's never seen before, and that's the mechanical pencil. You see, in his planet, they don't use mechanical pencils, so they have no clue what this thing is. So he decides to find out what this is by doing a series of tests on it. So first up, he does a clicking test, where he tries to push the back of the mechanical pencil in and see if it clicks. And to his pleasant surprise, it does, just like a normal pen. But he knows pencils don't click, so he gets really excited. He tells himself, hey, this might actually be a pen, something I've seen before. But then he wants to confirm his idea, so he does a different test, a writing test. This time, he uses the mechanical pencil to write on a piece of paper and does a series of chemical tests to find out what material does the mechanical pencil use to leave its imprint on paper. He knows that pens leave ink on paper and pencils leave graphite on paper, so depending on whether a mechanical pencil leaves ink or graphite, he would be able to categorize the mechanical pencil into either a pen or a pencil. So the results come in, and to his horror, the material imprinted on the paper is graphite. So now the mechanical pencil resembles a regular pencil. And that's just really confusing for this alien, because to him, a pen and a pencil are just two awfully different things. So how can a mechanical pencil behave like a pen in some contexts and a pencil in some contexts? So the mechanical pencil is to the alien what light is to us. Depending on what test the alien does on the mechanical pencil, it displays the properties of either a pen or a pencil. But in reality, the mechanical pencil is just a blend of both. It's got a bit of both characteristics in it, and depending on what test you do, it reveals the characteristics of either a pen or a pencil. The alien is just really confused by the existence of a mechanical pencil because it's nothing like the only two things it's familiar with, pens and pencils. The mechanical pencil is just beyond the comprehension of the alien because it's never seen anything like it before. So the same thing goes with light and us. Depending on what test you do, light reveals its wave-like or particle-like characteristics. If you do a double-slit interference test, it behaves like a wave. If you do a photoelectric effect test, it behaves like a particle. Light confuses us because we try to categorize it into the two things we're familiar with, waves and particles. But in reality, light is just a blend of both waves and particles that we're simply not used to.